Sir, no, I don't think we can handle this.
Just keep working.
Honestly,
just keep working, guys. Keep writing things down. I don't know what's
Sir,
going on.
I don't know what we can do. Who can we go to?
Uh-oh.
I got 23 students that are guys. Is anybody willing to help me out?
Just one.
Sir, I have a few hands up. I don't know if everybody's on board. I know it would mean the world to you for these young people to help you out. Sir, I can't do this alone. I think Tanner's on board. I got his table. Yeah. Okay, sir. I think we can handle this. All right, let's make this happen. We'll get back to you as soon as possible. Thank you.
I don't even really
We have a problem, guys. We have a situation that just came up, and we have a special message. So I need everybody to look at the smart board. Let's pay attention, please. Thank you.
Welcome to Space Camp.
All right. Want to know, or even some things that you wonder about.
Yeah.
You know, could
Excellent.
be I wonder kind of thing. Questions we have to answer.
Questions to be
Like,
answered.
how do we get rid of it?
How do we get rid of it?
Right.
Fantastic.
How did it start?
Dude.
How did it get there?
Alright, my question is space junk explosive?
Good. Keep going. Keep going.
If it came to Earth,
How could
cause, say, to be specific.
How much damage would it start it? Cause develop it in on Earth. Stuff that trash.
We have to write it.
Wait, I forgot. The space junk affects satellite clarity.
Wow.
Bring that up.
I've actually found some solutions to space debris.
What did you find?
I found something called a space debris removal using high-powered ground-based laser. Space junk.
Interesting.
Based on the way it is set up. Wind currency. I think it's gonna go past the wind. Yeah. Nah, it's not that. It's not that. It'll probably go.
A lot nicer than yesterday out there.
How high do you think it can go?
Yep, great.
Well,
Remember we talked about 3 stages of the Apollo?
write it down.
Yeah.
Maybe you can decide if there's 3 stages of that. North, that's south,
Oh, come on.
that's east, that's west.
Oh, that.
Wait. I don't want to.
9, 8, 7, 6, 5, 4, 3, 2, 1.
So we know that it's pretty much man-made. Did you find out what it's made up of?
People are using space as a big junkyard because that's where people put their trash. It goes in
I don't put my
can.
trash up there.
And sometimes it travels. It goes to the junkyard. And
Who are these people?
Just like people who go up into outer space to spacecrafts and stuff.
Okay.
It's like a big junkyard.
So you're
Space.
saying
So what do we do with space junk then?
what do we do?
Anybody have an
Do
answer?
we reuse
Actually,
Well, who has it?
Do you know?
I do have an answer.
Okay.
I researched satellites on the website, and it
Good.
said that one theory was to like bring all the old satellites that were dead like down to the Earth, where they could be like burned in the atmosphere, and maybe like burned on Earth.
Uh-huh.
But the only problem was that because maybe on the journey, like space debris could hit, and it would just cause millions.
Wow. Interesting. That's a great question now. That should have been up there. Will you write that down for me and put it back up here, please? Or still have to be further
Apparently,
research?
they also did also engineering nets,
Uh-huh.
But they-
There we go.
but they're still waiting on the scientists to get the measurements
Excellent.
for
How
the
big to make it and what to make it out of.
Right.
Cool.
They're also going to make it out of something hard.
So countries are compromising. So it's not just us.
Working
Other
together.
countries believe that it is a problem. Yes, sweetie.
Oh, also, I want to add on to like
Yeah.
growing up.
Keep going. Good.
Like, you can shoot lasers.
Back to that shooting lasers. What was
That the signals, how they get it is they go through different stations and goes to the tower and then hooks up to the satellite and then communicates with that.
right?
I asked Roger a question saying could we mess up the signal with the radio and with the radio waves, and the answer was not really. The only weather that can interfere is lightning.
Up and down, up and down. So it's sort of like a roller coaster too with the bumps. You go up and down, up and down.
Okay.
And amplitude.
Good.
Fantastic.
Do it.
Amplitude is how far the height of a wavelength and how far from crest to crest.
Okay, what is how far from crest? Can you label those?
Like at one point there's a higher or a lower frequency, and then at another point there's a lower frequency. That's why it gets smaller.
Compression is when you see the most.
Okay. Okay. And so, how would you use the string to?
Stop.
Good job.
Very good. Great point, Joe. And Armando. Great point. That's why we have a group.
How many centimeters?
Centimeters?
They're up to the nearest half inch, so it's 11, 11 and a half, what, or centimeters.
Everybody's gonna write it. Okay, so
What'd you guys get?
like right there, so that's like in the middle, it's 9, so
It's in the middle of 11 and 12. It's like with these lines right here.
it's 11 and a, you said closest.
To the nearest half.
Okay, 11 and a half then.
Okay.
Well, because the cylinder's going faster and the ball, the marble is going faster and the ball bearing is more heavier. So that it will go slower.
So you think since the ball bearing has more mass, it's going to go slower?
Yes.
Okay, so you said that the marble is going to make the cylinder travel farther.
Yes.
Okay, I think we're good. We've heard everybody's hypothesis.
Marble
You ready?
first.
Marble first.
Ready?
Go. Do you think the ball bearing will make the cylinder like 20?
7 centimeters. 7 centimeters.
Yeah, 7 centimeters.
Okay, make sure we're recording it in the correct location.
7 centimeters.
And go! Oh, that's better. Much better.
Wait till across the line, Reggie, right?
And just quick put it in there upside down. Whoa! What'd you do?
What'd you do?
Holy smokes!
The water vapor.
What happened?
All the water steamed out.
What happened?
What is supposed to do that? Yeah.
Why?
All the water steamed out and the water vapor just kept rising and rising.
Pressure is kind of like a big weight. So that's why when you go in the deep end of the pool, you feel like you're being squished because the water pressure is pushing down on you, just like air pressure is.
Okay.
Okay. Ready? Go. Go.
Oh! Okay.
Oh yeah.
Now compare it. Put it beside the other space junk.
Oh snap!
Well, did it crush as much?
No, not at all.
Put it next to the other can the same size. Look at that. So tell everyone in the group what was different about these two cans.
The water.
Amount of water in the
How much was in the how much was in this can?
50 milliliters.
And how much was in that can?
100.
Both at 100 degrees Celsius, right?
So you could probably make an inference off that, right?
An inference, yep.
So
That's awesome.
the more mass and density there is in the object, then the less they crush.
Wait, that doesn't make sense. Our group, we have.
Did it have the same mass though?
There you go.
Johnny, you gotta make it straight. Right straight. So one. Wow, that's a big crater.
Wait, let me be in too.
Oh, it hit the rock.
Okay,
What are you guys creating here?
we are trying to make the smallest crater. So we decided that we were going to drop it from 30 centimeters, and we were going to use the really rocky stuff for our soil, and that we were going to use a marble for our object.
Good. So is the object? Are you trying to make the object lighter or heavier? All right. Tell us. Hold on. Tell us about your soil.
So we combined with sand and just like this high water dirt.
Okay. And what is the mass of your object that you're using?
I think 313 grams.
313.
And you're trying to make the biggest crater?
Yes.
Okay.
Oh.
Okay, we should pull that out and measure that crater.
Let's use the protractor.
Okay.
Alright, across it is 4 centimeters.
In Mason Pond, what do you think is the biggest thing?
Probably like water.
The alligator snapping
Okay, big snapping turtle. Okay, fish. Good. What else might we find smaller than that? What do you think is the smallest thing that we're going to find in this pond? You think? Yeah. Dragonfly. Algae. Interesting. Yeah.
Tadpole.
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 Fish. Tiny fish. Yep. Fish eggs. Yep. Mosquitoes.
Oh, mosquitoes?
Yeah.
Space camp here is really cool.
So much better than in school.
So much better than in school. I don't know what it's in there. Let's go, River. It's not like garden. All that junk in outer space really is a big disgrace. Our job as back is plain to see. We must tackle that debris. Space junk. Space junk. Bring it on down. 1, 2.
We're gonna catch it first.
Yeah, it's a lot colder. Can you feel the temperature? It is. Well, wait, let's wait. Can we now?
It kind of looks like it looks like 6. That one looks like 6. The other one looks like 3. Now it's starting to look like this color, but that's what I just said. Start it over. Alright.
And for one brief moment, for just a few seconds, you're out at sea or on an island in the middle of the Pacific or out in the Atlantic, have the ability to see the sun really set. You can also see what's called a green flare, which momentarily
this is, if she was a planet, if she was a major planet, so you don't want to bump into the sun, that'd be, dangerous. But as she's revolving around the sun, you'll notice there's not any other stuff in her way. Now, let's say, Stephen, can you do me a favor? Can you start revolving again? And can you start following her? Exactly. Stop her creeping. Exactly. So now all of a sudden there are two things in that one orbit. So the third rule is that if you're a major planet, you can't have other stuff in the orbit. You have to clear out your orbit. So the stars we're seeing, that are in some cases thousands of light years away, we're actually seeing thousands of years in the past. And for example, the light, you guys know that the sun is a star as well, right? Yes. So do you know how long it takes the light from the sun to get here?
8 seconds.
Longer than 8 seconds. Yes, 8.5 minutes. So that means the light we're looking at from the sun is actually the sun 8.5 minutes ago.
Together first, maybe make a few.
That's too big.
Put these metal wires to it. They bind it up. As you can see, the fixed the bales are already done, and they strap it down, and then it gets pallet jacked out and then forklift up into.
Nobody told me that. 5, 6.
Well, I got a sign and we did that one. Tell me what we have.
Take a minute. 6, that's 6.
We got it.
Yeah, that's 6.
I'm not that.
I like the thinking.
I'm not good at sewing, so bear with me.
Guys, hey, come on.
We can use some of his square because we don't know how to do this. So we're gonna like connect it and then cut wire and cut it. But we're gonna cut it up and then we're gonna do a patch in it and then we're gonna like tape it and then we're gonna do more crochet.
I saw 3.
They're up there. You are Armando. Pull it.
Five, 4, 3, 2, 1.
What the heck? I told you. It's not even going on me. We need to make a ball. It's not even going onto the.
10,
5, 4, 3, 2, 1.
They got more.
collect all that little debris?
No.
What's it going to do when it hits the atmosphere? It's going to sever it up. So you may want to consider something when you go back inside.
Right.
May want to consider.
Last one because it was like the teacher about to have like a lot of schools things to help you with. You just have yourselves and your partners to help to figure your way back, to figure out your way back to Kansas.
I like all of them. I like the first one because it was like all of us, and we were like finding our direction, and stuff. You know, we used tools, map, binoculars, compass, not numbers, fractions, space jump. Then the GPS will not like function, and then now they don't know where to go, and it also might affect traffic lights.
You're going to get back. All right. Thank you very much for coming out. It was very nice meeting you. Very nice meeting you too.
I'll catch up to you.
Angle it to mine if you can, Reg.
Sorry. Reggie, angle it to mine.
Angle it to me.
And this is just
I'm not trying to hurt your eyes.
See, so far I see it on Sarah's.
Alright, Reggie.
Oh.
Keep it steady, Sarah.
I'm trying.
Let's get it going.
Hold your hand.
Steven,
So it
angle
depends
yours.
on
All right, Steven,
not wiggle it.
you got it. See if you can angle it, Steven.
Right there. We got it.
Tell us what our big problem is. Space junk. What's happening with space junk?
It's trash.
It's polluting, it's trash, it's dead satellites. What are some potential things that could happen with that space junk that we found out? Nico? It could crash through the atmosphere, right? We talked about it being floating in the atmosphere and some things that we can do to prevent it, like making nets, using magnets, all of those things. But what if we can't prevent it and it enters our atmosphere and it's here on Earth? Okay, so that's kind of the part we're focusing on today. That it's not prevented from entering the atmosphere, it's falling down to Earth, and now we have this space junk in front of us. Okay, so think back to waste management and recycling, and think about some things that we could do with that space junk once it's in our hands here on Earth. What do you think, Stephen?
Turn it into a work of art.
You could turn it into a work of art. What gave you that idea? Your surroundings, right? So this is giving you the context or some ideas on things that we could do.
Wait, what number are we?
Doing a slash. You are on 5.
Okay, the more power we have,
The bigger the splash will be.
this is that the tap water will create the most tsunami.
before we take it out? You can take that out for a minute. So it's not training for the session. Okay, now you're going to test.
Which one? Paper cut?
Okay, 1 minute.
It
Still
worked.
magnetic at 1.
Yep.
Still connecting at 1. So you have.
It'll let you
Go.
know.
Okay, take it out.
Careful. Go ahead, go for it.
Can't even pick it up.